Hey guys, welcome back to chapter 12. In this video, we're going to work another problem where we determine at what temperature something becomes spontaneous or not. So here's our problem. Determine at what temperature, if any, the following reaction becomes spontaneous. So first, one of the things I noticed is that the signs of enthalpy and entropy are the same, so negative and negative. When the signs are the same, that tells me that this will be spontaneous at either high temperatures or low temperatures. So it's temperature dependent is what that tells me. So to solve this problem, we are going to determine at what moment this goes from spontaneous to non-spontaneous. So here is the equation that we're going to use. The moment at which this would change from spontaneous to non-spontaneous is when delta G equals 0, right? So we're going to determine the temperature at which delta G is 0, and then determine if it's higher than that temperature, spontaneous, or lower than that temperature, non-spontaneous. So we're going to set delta G equal to 0. So I'm going to click ahead just so I have some space to work. So again, here's my equation. Gibbs free energy is the change in enthalpy, and that's the standard, minus temperature times the change in entropy. Taking inventory of what I know and what I'm solving for, just kind of making sure my units are also intact. All right. So we're setting delta G equal to 0. Enthalpy in this case is a negative 98.9 kilojoules. Temperature is what we are solving for, so we're trying to determine at what temperature this delta G equals 0. And then our entropy is negative 94 joules per Kelvin. So I'm going to write that down, negative 94 joules over Kelvin. So remember, eventually we need to add and subtract these values. So I need to make sure that my units for energy are identical. So you can either go both to kilojoules, you can go both to joules. I always choose to go to kilojoules, so I divide by 1,000. So this is going to be negative 0.094 kilojoules over Kelvin. Now we're going to plug these values into our equation and chug through it. So delta G equals 0. Enthalpy is negative 98.9 kilojoules minus temperature times negative 0.094. All right, I'm going to move this 98 kilojoules over to the other side. So it is a negative value. The inverse of that is to add it. So plus 98.9 kilojoules. So those cancel. Whatever I do to the right side, I also have to do to the left. So cleaned up, this is going to be 98.9 kilojoules equals negative T times negative 0.94 kilojoules over Kelvin. All right, so I'm going to get this temperature by itself. So I'm going to divide by this negative 0.94 kilojoules. I lost the 0. Lost the 0 in here. Here we go. All All right, so I'm going to divide by that negative 0.9 kilojoules per Kelvin. Whatever I do to the right side, I also have to do to the left side. Divide by 0.094 kilojoules over Kelvin. My units for a kilojoule, so kilojoules on top, kilojoules on bottom, those cancel, and we're left with the unit of Kelvin, which is good news because we're solving for temperature. Now I'm going to plug those values into my calculator. So 98.9 divided by negative 0.094, and I get a big value. I get a value of negative 1052.1. And then I have a negative on the left side, a negative on the right side, so negative T equals this negative Kelvin. So we can divide by -1 or just know that those cancel. And so the temperature at which this switches from spontaneous to non-spontaneous is 1052.1 Kelvin. Now we have to decide if it's above that temperature spontaneous or below that temperature spontaneous. So if I look back, we're in the scenario where enthalpy is negative, entropy is negative, so negative, negative. So we're here in our table. So what we know is that when enthalpy and entropy are negative, that will be spontaneous at low temperatures. So to answer this fully, we would say below this temperature, it becomes spontaneous. Okay. That's our second example of these. I think that's the last one. You will definitely see these on your exam. I hope you found this helpful.